In our last lesson, we studied about electronic configuration and we learned how to do the electronic configuration from 1 to 20 elements. Today we are going to do some more electronic configuration of some a little difficult element. So many things will become clear to you. Now, I hope you know or remember what you saw in the previous video, but just for a revision, remember when we talk about the subshell, we have four subshells S, P, D, and F. S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. Then the order of filling of subshell was like this: 1s, 2s, 2p, 3s, 3p, 4s, and so on. If you're still not sure, you can go back to the previous lesson and observe it. Then I again showed you the order of filling of subshells, how we fill up the subshell. I hope you have understood that. If not, again, you can go back to the previous video and watch it. Let's move on. Now, this is something new. Now, the elements uh, in the different blocks, for example, the S block, the P block, the D block, and the F block. They are known as S block and D block and P block and F block. Why? Because it is according to the valence electrons which are in this orbital. For example, if we talk about, suppose we talk about lithium, Li. Lithium has an atomic number of 3. That means it has 3 electrons and 3 protons. If we write its electronic configuration, 1s2 and 2s1. So you'll see the valence electron is in s orbital. So we write it as that, therefore it comes actually in S block. Whereas if you take another example, suppose we take an example of nitrogen. Nitrogen is 7. So 1s2, 2s2, and 2p. This is 4, 5, 6, 7, 3. So this becomes 3, 4, 5, 6, 7. So again, we'll see that the valence electron is in p orbital. Therefore, it comes under p block. Likewise, you will see that the elements coming under different blocks are called according to the valence electron that is in those orbitals. So therefore, we call it as S block, D block, P block, and F block. Let's move on. Now, let's do some more electronic configuration of some little difficult elements. So let's start with scandium. Now, again, I hope you remember in the bracket we write down argon, which is 18. So 18 electrons are already taken. This is a shorthand method of writing. Instead of writing the whole, uh, we can say electronic configuration takes a lot of time. So we can shorten the electronic writing of electronic configuration by putting argon in a square bracket, and then we can write down 3d1 and 4s2. Another thing you will notice over here is we write the 3d before the 4s. Now, this is because the electrons occupy the orbitals with lowest energy. The 3d subshell is just above the 4s subshell, but below the 4p subshell. So we write the 3d before the 4s. Let's write down the electronic configuration of titanium. Here again, we can enclose argon in a square bracket and then write down 3d2 and 4s2. So argon is 18, 19, 20, 21, 22. Let's move on to vanadium. Vanadium 23. So let's put argon over there and then 3d3 and 4s2. So 18, 19, 20, 21, 22, 23. Let's move on to chromium. Chromium will be, again, let's put argon there and 3d 5 4s1. Now if you look at this, you'll again wonder why we wrote 3d5 and 4s2, not 4s2. So instead of writing 3d4 and 4s2, we are writing 3d5 and 4s1. This is because 3d5 4s1 electron arrangement is more energetically stable. So therefore we write this. So this one is not correct. So we can rub this. So I hope you have understood it. Let's move on to manganese. Manganese is 25. So let's put this in the bracket. Argon and then 3d5 and 4s2. Now this 5 is a little, let's rub this and write it more neatly. 3d5. Let's move on to the next one, that is iron. Iron is 26. So let's put argon in the bracket, then 3d 6 4s2. Let's move on to cobalt. Argon, then 3d 7 and 4s2. Let's move on to nickel. Nickel is 28. So argon 3d 8 and 4s2. Then we move on to copper. So if you look at copper, again you will see we are writing 3d10 and 4s1. So you saw in chromium and again copper. So instead of writing copper as expected as 3d9 and 4s2, we write this one. So the reason again over here is similar to what I said before. What did I say? I told you that 3d10 and 4s1 electron arrangement is more energetically stable. So these two elements, that is copper and chromium, are comes under exception in pattern. So remember them, please. Don't mix up. I hope you have understood it. Let's do the last one over here, and that is zinc. Zinc is, again, you can enclose argon over here, 3d10 and 4s2. So these are some examples which were a little difficult, especially when we talk about the exceptions like chromium and copper. I hope you have understood it. Students, if you like my videos, like my lessons, chemistry lessons, please subscribe and like this video. That is going to encourage me to make more videos like this. Thank you, students.